We're solving problem 13 from the 2025 AIME2. Let the sequence of rationals x sub 1, x sub 2, be defined such that x sub 1 is 25 over 11 and x sub k plus 1 equals 1/3 times x sub k plus 1 over x sub k minus 1 for all k is greater than or equal to 1. Then x sub 2025 can be expressed as m over n for relatively prime positive integers m and n. Find the remainder when m plus n is divided by 1000. So for this problem, it begins with some algebraic manipulation right here. We see that this is not its like most simplest. We don't like how it looks here because we have a reciprocal, and we don't like that. So what we want to do is first simplify this bit a little more. So what we can do, we do x sub k plus 1 equals 1/3, and we just put x sub k on the denominator. So this is x sub k squared minus x sub k plus 1 over x sub k. Now we realize in this case, this is the top. You see, it looks like a familiar form, right? And it's familiar because this is the form of one of the terms of a cubic polynomial. So if you multiply this by x sub k plus 1, all of that just cancels out to x sub k cubed plus 1. So we can do that. X sub k plus 1 equals, I'm going to put the 3 on the bottom now, but when you multiply this by x sub k plus 1, we're going to get just x sub k cubed plus 1, all divided by 3 x sub k, and then you're going to have to divide by x sub k plus 1, what you multiply to get from here to here. Now, the problem, it says that x sub 2025 can be expressed as a fraction m over n. Therefore, we can let x sub k be m sub k over n sub k, and x sub k plus 1 is therefore m sub k plus 1 over n sub k plus 1. Plugging it into here, m sub k plus 1 over n sub k plus 1 is equal to m sub k cubed plus n sub k cubed over 3 times m sub k, n sub k, and m sub k plus n sub k. Now this here, what we can do in this case, we can we can factor out a term. This one now, and this becomes m sub k squared minus m sub k, n sub k, should put parentheses, and then you do plus n sub k squared over 3 n sub k times n sub k. So here, this is the point where you realize this can be simplified even more when you just want to sum m and n, the numerator and the denominator. So it does not become, but we want to solve for 3 m sub k plus 1 plus n sub k plus 1 is equal to, I should probably write this here. This is equal to m sub k squared plus 2 times m sub k, n sub k plus n sub k squared. So we see this is a square, and we can divide by 3 to get that m sub k plus 1 plus n sub k plus 1 is equal to m sub k plus n sub k squared all over 3. Now this is simply what we get. So all we have to do is literally just list out the terms and then do mod 1000. After doing that, you will obtain our answer of 248. So that is our answer for this problem.